In this demonstration, we will discuss how to import Onshape CAD models to be used in PyDrake. And regarding that, we'll be using Visual Studio Code, which is an IDE platform for Python development. First, let's open the GitHub repository, which you can see is already been opened here. Then we'll go to code and copy the GitHub link. Now let's open Visual Studio Code. Since Visual Studio Code is already open, so I need to create a new instance of the VS Code. Now we will go to View and Terminal so that the terminal can appear. Now we will type git clone and the link, but first we will change to the documents folder and then we will type git clone and link. Once the cloning is complete, we will open the project. This is the PyDrake library, which I have created for you. So inside the PyDrake library, you have the script simple pendulum from URDF file, which is the main script which you will be running. But before running, you need some supporting files that will be used by the Python script. Those files will be generated by step 1, step 2, and step 3 scripts. First, there is a bash file, and second, 2 Python script files. Now you have a folder called model using Onshape to robot. Within that folder, you have simple pendulum. And you have 2 files, there is config.json and .env files. The .env files is used to store the API credentials of Onshape, and the config.json file points to the assembly file which you will generate after your CAD modeling. So you need to put the URL of the assembly file in the config.json. The first task is to populate the .env file with your Onshape access keys and API. Let's see how we can generate these keys. So get to our Onshape web page, go to my account, log in. Now navigate to developer settings, then API keys. Now we need to generate a new API key. Let's create one called PyDrake_lecture. We will give it permissions for all operations, but you may choose what to do. It will be failed because at a time you can only create 2 keys. I've already saved my keys, so I'll use those, but you can see how you would generate keys through this process. I'll directly copy and paste the key from my desktop. There we go, we will save it. Here we need to paste our assembly file's URL. Let's go back to the home page and navigate to our assembly file. So this is our assembly file here. It's a card pendulum. What I have done is weld the card to the rail. However, you can add a prismatic joint and make it a card rail system as well. Let's copy the URL and paste it into the config.json file. Both the JSON and the environment file needs to be created. However, I have created a template for you so that you can use it. And that's it. We are done with the configuration. Before we move on, I want to quickly point out how to save your assembly file properly. There's a specific way you need to name your joints. You should save the joint name with DOF or something similar as a suffix. With this DOF identifier, the API is able to recognize which part in the assembly represents the joints. These joints are created from the Onshape interface. You can experiment with creating different kinds of joints. Let's move on to step number 1. Now we can proceed to running the bash script. So this is a bash script. I've already created shortcuts to run these tasks directly using the task.json file in VS Code. This is a very convenient way for running different scripts. We have the first task for the bash script, the second for the Python script, that is step 2 and step 3, and finally one for our main Python script. Let's run the first task. So we need to press Command-Shift-P. Before we run it, I realize we need to install the Python environment first. Let's go and set up the environment. Go View and then Terminal. we have a README file here that we can preview for the installation steps. It shows all the steps we need to complete. Since I already have a PyDrake environment, I'll just use another environment named PyDrake_lecture as the new environment name. You need to create the environment. We need to activate the environment and then install the required packages. Once we install the packages, we will move on to setting up the Onshape to robot workflow. Let's activate the environment first. Let's install the required packages. And finally, let's install the Onshape to robot, TriMesh, PyMule, PDF, Matplotlib. Onshape to robot is the API. TriMesh is for URDF to, STL to OBJ conversion. Now let's go to the Onshape import process. Let's review the Onshape documentation. As you can see, the instruction for adding the API keys have already been provided here. We have also documented how to generate the JSON file. This is the bash script which you will be using. Let's try to run the generation process. Right now you can see that the simple pendulum folder already contains the config.json file. Let's see what happens when we run step number 1. We will run the task and then we will run the first one. You can see that now we have an assets folder. However, in the assets folder, we only have part files and STL files. Remember that PyDrake cannot use STL files directly. At least I have tried extensively, but I cannot. That's why we need to create OBJ files, that's the object files. So that's where step 2 comes in. You can see that the OBJ files corresponding to the STL files have now been created. Now the next part in the simple pendulum folder is the URDF file which was created in step 1. You can see that this URDF files contains STL files references. Of course, you can do this manually, but it's much easier to do it. So we need to create another URDF files with OBJ files references. Once we run step 3, another URDF files will be created with OBJ file suffixes. You can see that the mesh file names here reference the OBJ files that were created in step 2. We are now done with all the pre-processing steps. Now we can move on to the main script file and start running the simulation. Let's run the task and select Run Simple Pendulum. For the simple pendulum simulation, we can start with just a simple display mode. Once it starts running, you will see a WebSocket link appears. Just click on it and you will be able to see the GUI, that is Meshcat visualization. Let's try moving something. So the pendulum will move 10 degrees if I type 10. The pendulum will move minus 45 degrees in the other direction if I type minus 45. Let's try something else. Now let's try running the uncontrolled mode, which is option number 2. Now you can see that the pendulum is moving freely. There is a damper component at the joint. So the pendulum is slowly coming to the equilibrium point. This is the plot showing the simulations. You can see that the angle is continuously decreasing and angular velocity is also reducing. The state trajectory plot shows how to keep approaching to the equilibrium point. Next, we will try the LQR control mode, which is the third mode. Let's run it. You can see very quickly that it reaches equilibrium. It's very hard to visualize in Meshcat because it's very fast. And this is reflected in the plot. You can see that the angle quickly goes to 0 and the angular velocity also goes to 0. The straight trajectory shows that it moves directly to the equilibrium point. This concludes the complete demonstration. Thank you for watching.